This is example 3 of the solving linear systems, substitution, elimination, and calculator methods. We have a system of linear equations here, 4x plus y is equal to negative 23, and x minus 2y is equal to negative 17. And we want to find if it has a solution. There's three possibilities. That the two lines intersect exactly once. If they're lines, they can only intersect once. Where we have an ordered pair as a solution, which is where they intersect, and our system is consistent. Or the two lines are parallel, which means they'll never intersect or touch, so there's no solution and the system is inconsistent. Or the two lines are the same, so they overlap one another, so there's infinitely many solutions and the system is dependent. So those are three possibilities. We want to solve this by elimination. The way we do that is we're going to essentially multiply and get rid of one variable, either x or y, by multiplying one equation by a number to essentially facilitate after we add both of these equations together to get rid of a variable. So looking at this, we could either multiply this x by negative 4, and then essentially to make everything the same we'd have to multiply the entire thing by negative 4, and then can add the whole equation, everything, and then cancel the 4. Or we could look at this y here. There's already a negative here, negative 2y. If we multiply this first equation by a 2, then we'd have plus 2y minus 2y, which would cancel after we add them. So I'm going to choose that. So I'm going to multiply this first equation by 2 on both sides. So writing it down here, 2 times 4x is 8x. 2 times y is plus 2y. And then 2 times negative 23 is negative 46. So, and I'm going to write down this, I'm going to tag on this bottom equation. So you have x minus 2y equals to negative 17. And what we're going to do to get rid of this variable y is we're going to add everything. So everything here is going to be added. So the way we're going to do that is we're going to do adding downwards. So we have 8x plus 1x, that's 9x. Positive 2y minus plus negative 2y, well that cancels to 0, is equal to, that equal to just comes down, negative 46 plus negative 17 is negative 63. So altogether, we've written this without the 0, we have 9x is equal to negative 63. So you see that because of this method, we eliminated this y. So now we have solving for x, dividing by 9 on both sides. We have negative 63 divided by 9, which is negative 7. So we've solved for one of the variables from our system up here. And now what you can do simply to find our y is to take our x is equal to negative 7 and substitute it back into either of these equations. So I'm going to substitute it into this equation here of my choosing, simply because I think it'd be easier. So having x equals negative 7 into this equation right here, we have negative 7 minus 2y is equal to negative 17. Adding 7 on both sides, we have negative 2y is equal to negative 10. And then divided by negative 2 on both sides, we have y is equal to positive 5. So we have a solution. We have a solution at point negative 7, positive 5. So our system, so we go back to our handy little table, has a solution and it's consistent. And we can actually see that if we graphed these two lines, we could also see that they intersect at this point, negative 7, 5. So here's our two lines written out, and you can see that they intersect at negative 7, 5.